For this video, I'd like to talk about the concept of factoring. And factoring, to me at least, is essentially the reverse of the distributive property. So here I have an example set up where I want to distribute this 2 to each of these terms. So I'd get 6x squared plus 4x plus 2. And factoring, like I said, is essentially the reverse of this. So when factoring, we're going to look at our expression and essentially ask, with each of these terms, what is the greatest common factor? So it's usually written as the GCF, but ultimately it stands for the greatest common factor. And essentially what we're looking for is the biggest number that divides evenly into all of these terms. And essentially the number 2 would divide evenly into all of these. And so we can factor that out. And essentially what we'll end up writing is just this right here. When we factor the 2 out, we want to think, what do we have left here? Or essentially 2 times what would give you 6x squared? And that would be 3x squared. And 2 times what would give you 4x? That would be 2x. And we know 2 times 1 would give us 2. So this equation, or this expression here in yellow, this is what we would call factored. We have taken out the greatest common factor, which was 2 in this case, from the expression. And with that in mind, let's look at some different example problems here. So this first one in green, we've got to factor out 4x squared minus 16x plus 40. So we have to find the greatest common factor in this expression. And essentially we're looking for the biggest number that divides evenly into all of these. And what you can see is that each term is a multiple of 4. So we can essentially factor out that 4 from each of these. So you'd have 4, and then you want to think, what do you have left? So we know that 4 times what gives you 4x squared? That would have to be x squared. And 4 times what would give you minus 16x? That would have to be minus 4x. And 4 times 10 would give you 40. And once you actually factor out, you want to get in the habit of testing your factoring just to make sure that it's actually correct. And the way to test it is to just redistribute that number that you factored out to each of the terms. So when we remultiply it out, what you see is you get 4 times x squared. 4 times minus 4x would be minus 16x. And 4 times 10 would be 40. And since that is exactly what we started with, we can feel confident that this expression here is factored. Though I should mention that one habit you also want to be in is once you do factor out, you want to make sure that there's nothing else that you can factor out. And you can see that that's the case here because the coefficient on x squared is 1. So we're not going to be able to factor out any kind of number from each of these. So the only thing we could factor out would be an x term, but the 10 doesn't have an x. So we can't factor out x and we can't factor out a number, so that means that this is as factored as we can make it. And going to the second example here, we want to think, what is the biggest number that would divide evenly into all 3 of these terms? And it looks like the number 3 goes into all of these, so let's just start with factoring that out, because sometimes you may not be able to factor everything out the first try. Sometimes it's just not completely obvious. But if you're not sure what to do, my recommendation is to just ask yourself, what can you factor out, and start from there. And you can notice that each of these terms are a multiple of 3. So when I factor the 3 out, I'd be left with x cubed here. When I factor the 3 out from here, 3 times what gives you 6x squared? That would be 2x squared. And 3 times what gives you 27x? So that would be 9x. And essentially at this point, we just want to ask ourselves the question again, can we factor anything else out? So from these 3 terms, is there anything they share in common? And notice that each of these terms has an x in it, so we can factor that out. So essentially we'd have 3x, and then we want to think, since we pulled one of the x's out here, we just have 2 of them left. And again, we pulled 1 out here, so we just have 1 left. And on this one, we pulled out the only x, so that would just be 9. And again, you can remultiply this just to test it, but what you'll see is that it does, in fact, equal the original expression. So let's look at a couple more example problems now. So we'll start with this one. Which expression is the result of factoring the expression below by taking out its greatest common factor? So I'll just rewrite it. We have 16x squared minus 8x. We're looking for the biggest thing that divides evenly into both of these numbers. And you can see that they're both multiples of 8, so we can factor an 8 out. And they both have at least one x, so we can pull one x out from each of them. So essentially, we can factor out 8x. That is our greatest common factor here. And what we're left with, when we pull out 8x here, we have to ask 8x times what gives us 16x squared. So it would have to be 2 times x, since these multiplied together do give you 16x squared. And we pulled out an 8x here, but you want to think, what did you leave behind? Since it's essentially what number multiplied by 8x would give you minus 8x, and that would have to be minus 1. So we can retest this, and I always recommend that. So remultiplying it out, you'd get 16x squared for the first term, and then 8x times minus 1 would be minus 8x, which is exactly what we started with. And this type of problem actually brings up one of the most common mistakes that I see, where let's say you have 2x squared plus 2x, and we can factor out a 2x from this. So what you'd be left with is just an x for this term. And what I see a lot of students do is, since we pulled the 2x out, a lot of students think that this would be 0, since there's nothing left. We pulled everything out. But when you test it, you can see that this can't be true. Because when you re-multiplied it out with the distributive property, you'd get 2x squared for the first term, and then you'd have 2x times 0, which is 0. So this is obviously not the original expression. So this can't be right. So basically, that's why it has to be 1. And like I said, you can always just retest it. So if we put 1 in there, then you get 2x squared, and then 2x times 1 is 2x. So you do get back this original expression. So just be careful about making that mistake. That's one of the most common that students actually make. And on to this final problem here. So now we have kind of this visual model, this area model. And I'm just going to redraw it below. So we have this rectangle that's essentially split in half. Just draw a line down where this is 6x squared and this is minus 18. And one side length is 6. And we don't know what the width is. I'll call it w. So basically, we have 6 times w is equal to the area of this rectangle. And that would just be the area of this box plus the area of this one. So you'd have 6x squared minus 18. So basically, 6 times what would give you 6x squared minus 18. So if we start on this side to try and figure out what w is, let's see if we can factor something out. And what you can see is that each term is a multiple of 6. So I'm going to factor a 6 out, and I'd be left with an x squared here. And when I pull 6 out from this, we ask 6 times what would give you minus 18. And that would be minus 3. So when we factor this out, this 6 times w is 6 times this expression here. So it looks like our width is this x cubed minus 3. And in a later video, what you'll see is that we'll look at problems like this, where we have some quadratic equation and we need to factor it. And essentially, these factor into a product of two binomials. So you'd have x plus 2 times x plus 1. So in a later video, I will show you how you can actually get this result.